Okay, you believe this 90% of time, right? So the theta that it will be fair. The theta, if the theta represent a fair coin, then this belief should be much higher, right? Maybe 90%, right? But if you get that coin from a magic shop, then, well, the belief that this coin is fair is much lower, maybe 10%, right? So something like that, okay? So you can come up with your own prior, okay? So the use of prior, okay, the use of priors in Bayesian data analysis is why some people still talk about Bayesian statistics as a subjective. They don't think Bayesian statistics is because Bayesian statistics talk about priors, and prior is about sometimes it's about like your own belief, obviously, okay? So some people attack that, okay? But actually, such a prior is just an assumption, okay, that we made, okay, when modeling, okay? So just as subjective or objective as any other assumption, okay, such as likelihood, okay? Likelihood is actually a formula, okay, that we are going to talk about, okay? Likelihood is how we will introduce data in our analysis, okay? It's an expression of the probability of the data given the parameters. So if you have the parameter fixed, then the probability that you have such a data is the likelihood. Okay? I mean, when we describe the likelihood like that, it looks difficult, but in reality, it's actually much more easier than you may think. Okay? So in some texts, you will find people call this term sampling model, statistical model, or just model. But anyway, I mean, we just call it likelihood. I actually checked like more than one textbook, okay, doing Bayesian data analysis, and the book that we are using this for this semester, both of them call this likelihood. And the other books, well, it depends on how mathematics oriented those books are. I mean, if the book is more mathematics oriented, okay, then it may have call this sampling model, statistical model, because but don't worry about that, okay? As long as we understand what we are talking about, it should be fine, okay? So once we have prior, once we have likelihood, okay, then we could have our posterior, okay? The posterior distribution is a result of Bayesian analysis, and which reflect all we know about a problem, okay, given the data in the model, obviously, okay? So posterior is a probability distribution for theta parameters in our model, okay? So it's a distribution, okay? It's a distribution. In rapid test kit example, okay, it is a single value, okay, which is close to 2%, remember? The reason for that is because it's a discrete case, but in almost all the case in Bayesian inference, okay, we are talking about distribution, okay? We're not talking about a single value, okay? So this distribution is a balance between prior and the likelihood. So the prior tell you one thing, likelihood tell you something else, and the resulting posterior is actually a compromise between these two, okay? So there's a well-known joke, okay? A Bayesian is a guy, okay, who vaguely expecting a horse. Okay, this expectation sort of describe a prior. Okay, describe a prior. Okay, and then catching a glimpse of a donkey. Okay, so this is the data the Bayesian guy obtained, and then strongly believes he has seen a mule. Okay, so well, that's the posterior. You guys know, you guys know horse, right? That's no problem, right? How about donkey and the mule? Horse is, I don't need to explain horse, right? Donkey 驴啊，驴跟那个叫什么东西？那个怪物叫什么的？不是那个电影里面那只 Talking Donkey。Shrek， 对 Shrek。You guys seen the movie Shrek, right? The guy, the donkey. I mean, is the guy in that movie that keep talking. Just cannot stop talking. Okay, so that's the donkey. Okay, which kind of looks like a horse, right? Okay, the mule is有点像鹿啊 kind of like a big deer. Okay, mule actually also has 那个脚怎么讲？那个它是那种一片的。Okay, but I don't know how to, but anyway, it's also kind of like you can say it's one kind of deer. Okay. So they look horse, donkey, mule. They are different animal, of course, but they look similar. So you can say mule is a compromise of a horse and the donkey. Okay, so this is like what Bayesian inference is doing. Okay, so this joke captures the idea of posterior being somewhat compromised between prior and the likelihood. Okay, so conceptually, okay, so we can think the posterior are the updated prior. Okay, once we have the data. Okay, so posterior from one analysis can be used as a prior of the new analysis. So this can be done iteratively. You get this posterior, and you can use this posterior as the prior for the next round of the inference. Okay, so this makes Bayesian analysis particularly suitable for analyzing data that becomes available in sequential order. Okay, because a lot of time we get data like in sequence anyway. Okay, so well, sorry, it's already 10:05. We're almost. Let's take 10 minutes break anyway. Okay, when we come back, we'll continue. We are almost done with the statistical part. Okay, and then we are going to talk about an example, which is much more down to earth. Okay.